David Smith here with another Flip Classroom math video. A few tips before we start. Remember that you can slow down or speed up the playback if that helps you follow along. You can also pause the video at any point to catch up with your notes or to try the problems before I explain them. Finally, you could turn on the captions and read my words below on the bottom of your screen. Today's topic, arithmetic sequences. So in this little unit, we're going to look at two types of sequences, arithmetic and geometric. But let's start with the arithmetic. So an arithmetic sequence is a pretty straightforward sequence. The definition is that each term differs from the previous term by the same fixed number. Okay? So this is like starting with one number and just adding the same number to the next term, to the next term, to the next term to get your number. So the way you can check that is if the difference between each term is the same, then you have an arithmetic sequence. So another thing we talk about with this is the common difference. That's that same fixed number. So all of these terms have a common difference, in this case, of 3. So the common difference for this one is 3. Now check this one out. This sequence goes down. It's a counting down type sequence, still arithmetic. So we go from 67 to 61 to 55, 49, 43, and so on. What's the common difference from this one? Check it out. The common difference is this is negative 6. So we're subtracting 6 from each term to get the next one. So in this case, we have a negative common difference. Okay, let's look at a formula for this particular type of sequence. So we're going to call this the general term formula, but another word for it is the explicit formula. And if you remember, the explicit formula is super useful because it lets you find, say, the 500th term of a sequence without having to calculate the first 499. Okay? So that's a powerful formula. So let's take a look at this particular sequence. Starts with 2, then goes to 9, 16, 23, 30, 37. So what's our common difference? 7. So we're going to introduce a variable here. Our d is common difference equals common difference. And in this case, that's 7. So let's break this sequence down, use a little bit of algebra, and that'll lead us to the formula for the nth term for this sequence. So, gee whiz. All right, let's take a look at this particular sequence. Starts at 2, goes to 9, goes to 16, goes to 23, 30, and 37. So if you look at that pretty quickly, you can see that our common difference is 7. We're going to introduce a variable here. D stands for the common difference, which in this case is 7. So let's start breaking down these terms, use a little bit of algebra, and then we'll be able to come up with a formula for this sequence. So term 1, that's 2. Term 2 is 9, but let's break that down. Term 2 is term 1 plus 7. Now another way to write that is 1 times 7, okay? And you're going to see why I'm going to do that in a second. So term 3, 16, it's term 1 plus 2 times the common difference. And term 4 is term 1 plus 3 times the common difference, and so on. So I think you're seeing where this goes. So now you have enough information to write the explicit formula for this sequence. So go ahead, pause the video, put on your thinking cap, and see if you can come up with that. Okay, so basically what you need to do is take this kind of notation and generalize it. Okay, so the nth term, we use the term un for nth term, is going to be the first term, u1, there we go, plus n minus 1. Right? Because fourth term we added 3 differences. Third term we added 2 differences. So this is going to be n minus 1 times the difference. And so that formula is going to give us the nth term of this sequence. And you can test it on all these numbers and you'll find that that works. Okay, I didn't quite finish up that last example. Okay, so let's see if you can do that for me. Here's my sequence. Here's that general plug-in step. Here's the plug-in step where we finished. Now this can be simplified. So go ahead and do that. Okay, let's see how that ends up. I got a distributive property there. So un equals 2 plus 7 times n is 7n. 7 times negative 1 is minus 7. So this is going to give us 7n minus 5. So that's the concise version of the formula for this sequence. The nth term is always going to be 7 times whatever that n is minus 5. That will give you the value of the nth term of that sequence. Okay, here's one for you to try. 3, 9, 15, 21, 27. So go ahead and figure out your common difference, figure out your formula, your ultimate simplified formula for this sequence. So pause the video, put on your thinking cap, consult your notes, let's see what you get. Okay, let's take a look. General form, and un is u1 plus n minus 1 times the difference. So let's do our first plug-in step. Un equals 3 plus n minus 1 times my common difference, which is 6. So this is going to give us un equals 3 plus 6n minus 6, which is going to give us 6n minus 3. So that's our formula. Let's write it again here. Un equals 6n minus 3. Let's test it. I'm going to pick 21. That's the 1, 2, 3, fourth term. So 6 times 4 is 24, minus 3 is 21. So yeah, it does work. Okay, here's another one for you to try. Here's my sequence. 76, 69, 62, 55, 48, and so on. Pause the video and do what it takes to come up with this formula, the explicit formula for the nth term. Okay, let's see how you did. Starting off with my general rule here, un is u1 plus n minus 1 times d. Okay? Now, what is d for this one? What's happening? We are going down by 7. So the d is negative 7. So now let's do our plug-in. un equals 76 plus n minus 1 times negative 7. Bring that negative down. It's going to be important. So now let's do our distributive property. Un equals 76 plus negative 7n plus 7. Now I put parentheses in here just to make sure we distribute this plus accurately on this. So check it out. This is going to end up being 76 plus 7. It's going to give me 83 minus 7n. That's 83 minus 7n. Or we could do it this way. Un equals negative 7n plus 83. So let's see if that works. Let's give it a test. Let's try it on 55. That's the 1, 2, 3, fourth term. So 7 times 4 is negative 28 plus 83. Negative 28 plus 83. I'm going to use my handy-dandy calculator. So I've got my handy-dandy calculator. Let's try that. 28 negative plus 83 equals 55. Okay, you might see a problem like this in the exercises that we're going to do. So here's a sequence. 5, 17, 29, 41, 53, and so on. The question now is 172 a term in this sequence? So we have this number out there. We want to know if it's going to get in the sequence. Now, of course, you could just keep on going and figure out, and if you got to 172, you would know. But if this number was a lot bigger, then that's way too much work. So think about how you might do this. Okay, if you thought, well, gee, I have to come up with the formula for the sequence first, you're right. So go ahead and pause the video and do that. Okay, let's do that real quick. Un equals u1 plus n minus 1 times the difference, which is going to give us u1 is 5 plus n minus 1 times d, which is 12. These terms are all separated by 12. Work this out. We're going to get 5 plus 12n minus 12. That's doing the distributive property there. So finally, to figure this out, we have un equals, what do we got there? 12n minus 7. So there's our function. There's our formula for the nth term. And now we can take a look at that. So let's just test it. Fourth term is 41. So 4 times 12 is 48, minus 7 is 41. So this does work on the fourth term. So we're in good shape. Now, think about what you might do with this formula to verify or disprove that 172 is part of that sequence. Okay, if you thought, well, let's plug the 172 in for un and then solve the equation for n, that's what we do. And the result will be, if n ends up being an integer, then we know that's the term number of the sequence. If n is a fraction or a decimal, we know that 172 isn't in the sequence. So let's do that. So I'm going to add 7 to both sides. 179 equals 12n. And I can already see that this is not going to work out for 172 because 179 is not a multiple of 12. But let's finish this out. Divide through by 12, and we get n equals 179 divided by 12. It's going to be 14.9, yada, yada, yada. 14.9. It's got a bunch of stuff going after that. So we know that this is not a term in that sequence. Okay, here's one for you to try. Is 341 a term in this sequence? And I brought over our nth term formula for this, our explicit formula, so you can use that. So go ahead and pause the video now and see if you can figure out whether 341 belongs in this sequence or not. Okay, let's see how you did. So we set un equal to 341 and we solve for n. And what we're looking for is we're looking for n to be an integer, no fraction or no decimal. So let's add our 7 to both sides. 348 equals 12n. Now it's looking okay. This is an even number, so it might be evenly divisible by 12. But let's check. 348 divided by 12 equals 29. So this one gives us n equals 29. So that tells us not only that 341 is part of the sequence, it's the 29th term in the sequence. So a word about summary for this kind of problem. We're just using it backwards, okay? So we found this formula so we can plug n in and find the number of the term. Now we're just going backwards. We're taking the number of the term and we're solving for n. And as long as n comes up as an integer, then that number is part of the sequence. Okay, here's a wrinkle on a sequence problem. K plus 5, negative 1, and 2k minus 1 are all consecutive terms in an arithmetic sequence. So they're in order and there's no skipping terms. So we know that this one plus the common difference makes this one, and then we know that this one plus the common difference makes that one. So we're going to exploit this idea. So the common difference is going to be this term, negative 1, minus k plus 5. Remember this, the second term minus the first term is the common difference. Now we can do this over here as well. We know that 2k minus 1 minus negative 1, which is the second term, this is also equal to the common difference. So since both these terms equal the common difference, they equal each other. Now we have one equation with one variable and we can solve that for k. So let's do that. So I have minus 1, we distribute my negative, minus k minus 5 equals 2k minus 1 minus negative 1 is a plus 1. I think you can see what's going to happen there. So let's rework this. Minus k, minus 1 and minus 5 is minus 6 equals 2k plus 1 minus 1 is just 2k. Let's add k to both sides. We get negative 6 equals 3k. Divide through by 3, divide through by 3, we get k equals negative 2. Okay, here's another interesting problem based on sequences. So this time, they're going to tell you U3 is 4. So the third term is 4 in our sequence, and U7 is minus 24. Okay, so we know this is a descending sequence. It's getting smaller and smaller, more and more negative. And we're being asked to come up with the general term formula. Whoa, that seems like a stretch. But actually, if you know this, you have enough information to do that. Okay, so if you want to give this a shot, pause the video right now and see how far you get. Okay, so one of the things we need here is we need the common difference. Okay, so there's a difference between the third term and the seventh term, right? So we're going to take the seventh term and subtract the third term, and that's going to give us negative 28. Okay, so we know the total difference between these two terms is negative 28. Now, how many terms did we go to get there? We started on 3, so we did 4, 5, 6, and 7 to get to the 7th term. So we applied the common difference 4 times. So this number is 4 common differences. So now if we minus 28 divided by 4, that's going to give us negative 7 is the common difference. So now we know our common difference. Now we still need to find that first term. So there's a lot of ways that you can do that. If I have negative 7 as my common difference, then I can just reel this backwards to u2 and u1. So I'd add 7 each time to get to u1. So u2 is going to be 4 plus 7 equals 11, and u1 is going to be 11 plus 7 equals 18. So now I know my u1. I just worked it backwards to get that. So now I can come up with my general form formula. So that's un equals u1, which is 18, plus n minus 1 times the common difference. So that's our plug-in step to find our general form. So now let's work it. un equals 18. Now let's distribute our stuff here. So that's going to be plus negative 7n plus 7. Now since this is all addition and subtraction, I don't have to worry too much about my parentheses. un equals 18 minus 7n plus 7. So now let's rearrange a little bit. un equals negative 7n plus 25. And that's our general form equation for the sequence with these two terms. Now if you want, you could pause the video and test it by putting in 7 for n and seeing if you get negative 24. So 7 times 7 is 49. We've got a negative. So negative 49 plus 25 is indeed negative 24. So we know this is correct. Now that you've finished, write down any questions so you can bring them to our next class and get some help. Remember that you can always watch the video again to improve your understanding. If you enjoyed it, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.